So we're going to talk about hypothesis tests, and I'm going to do basically what I did in school today with another example so you can see how hypothesis tests work. So let's start with this. We're going to do a study in which we are going to try and determine what the average GPA is of first-year college students. Okay? We believe that the average GPA for first-year college students is 2.0. Or 2.20, I mean. Okay? So we're going to call that our null hypothesis. Mu is 2.20. And I'm going to write a note here that mu is the average GPA of first-year college students. Okay? The alternate hypothesis is this. Mu is not equal to 2.20. So we are going to be equally interested if the true GPA, average GPA, is either greater than this or less than this. So we're testing against the alternative that the actual mean, the truth, is not 2.20. I'm going to give you some other information. The sample size we used is 200. Okay? The standard deviation is equal to, standard deviation of GPA for the population is equal to 0.40, and the sample mean equals 1.60. Okay, so that's what X bar is, 1.60. Let me write that again. That was kind of messed up here. So the sample mean is 1.60. This isn't a very good college, by the way. Okay, well, we won't go there. So the question is this sample mean far enough away from the null hypothesis mean to give us evidence that this is really not the truth? Okay? What I did in class is I said this is always step one, stating your hypothesis. Now we know that X bar is supposed to have a normal distribution, and that only happens if the conditions are true. So let's talk about the conditions and assumptions. So conditions, assumptions. The first condition is that we have a simple random sample. Okay, it wasn't stated, so we have to assume that this represents a simple random sample of the population. The second condition, remember, is either that the population is normal or that the sample size is big enough. Okay, now we don't know about the population being normally distributed, so, and the sample size is obviously much more than needed here. We only need 40. We've got 200. So we're going to go ahead and use that X bar is normal if n is big enough. And over here we'll answer that by saying since n is equal to 200, which is a lot greater than 40, remember 40 was our cutoff point, then n is big enough. And this was part 2. Okay, we have to have part 2 before we go on to part 3, and that is because part 3 is where we say what the distribution of X bar is. Okay, and if you want to stop it now for a second and take a look at what I've written so far, I'm going to go ahead and flip the page in just a minute. So go ahead and pause now. Okay, new page. We know then, since the conditions are true, that X bar is normally distributed. Okay? And you know what I'm going to do? I'm going to go grab the null hypothesis there. So give me a second. Okay, there, it's like magic. Here's the null hypothesis again because I need to refer to it. Since the conditions are true, X bar is normal. Remember, in a hypothesis test, we assume that H naught is the truth. If H naught is the truth, then the sample mean should be normal with the mean of the same as the null hypothesis. The standard deviation is 0.4 sigma over square root of n, 200. And so we find out that if the null hypothesis is the truth, then x bar is normally distributed with a mean of 220 and a standard deviation of, and I did the computations here, 0.02828. Okay, always go to 4 decimal places, remember that. Okay, now, this is step number 3. So let me put a 3 here. This is step number 3. Let's figure out what the distribution of x bar is. So now that we've got step number 3, we can take a look at the distribution of x bar, what it looks like as a graph. It's normal. Its mean is 2.20. Its standard deviation is 0.02828. This is the distribution of x bar right here. Okay, now, here's the secret with a two-tailed test. In a two-tailed test, we are equally as interested if the sample mean ends up being over here or over here. So we're actually going to have 2 rejection regions, and now we're getting into the rejection region method. We'll talk about that first. Rejection region method. Basically, what we have to do is identify the places to the right and to the left with critical values, and I call these x bar star 1 and x bar star 2. And the critical values have to be placed in such a way so that we get half of our significance level in each tail. Now remember, in class I mentioned alpha, significance level. And I said alpha typically is 0.05. Okay, if they don't tell you, you can usually use 0.05. If they do tell you, use what they tell you. What that means then is that we've got 2 regions, one on the left and one on the right, each one that has half of this significance level as an area. Now we've got to figure out what these 2 critical values are. Okay, so I'm going to go ahead and do that with my calculator real quick, and then they'll just pop up on the screen. Like magic. This left one has a left tail area of 0.025, so I can use the inverse normal function to figure out that this critical value has to be 2.1446. The critical value on the other side has to be the same distance on the other side. Okay, so let's see if I can do this in my head. 2.2554. I think I'm right. Yeah, my calculator says I'm right. So, there we go. If you figured out, I keep pausing the video here so I can do these calculations. Take a look at where our x bar is. Where is our x bar? It's 1.6. Well, 1.6 is definitely way over here on the left side in the rejection region. These 2 shaded areas are our rejection regions. Since 1.6 falls in that rejection region, we can reject the null hypothesis. So this right here, doing the work, finding the critical values and figuring out where x bar falls, that is step 4. And step 5 then is just doing the conclusion, and in the conclusion you have to have this comparison. So we can say, since x bar equals 1.60 falls in the rejection region, to the left of x bar star 1 of 2.1446, we have enough evidence to reject HO and say, and do that again, and so we'll say is what I meant to say. And so we'll say that the true GPA of first year college students is not 2.20.